What's up, Mustangs? Miss Titus here, and today we're going to talk about two new concepts to Algebra 1. The first is a relation. So at the top of your page in your iPod, we're going to define a relation. A relation is simply a set of ordered pairs. Okay? So, a relation is a set of ordered pairs. We have 5 different ways that we can represent a relation. Okay? So we're going to talk about each of the 5 ways today. The first is ordered pairs, or a list. Now, we use these brackets on the outside to denote that this is the beginning of our list. So let's say one of my ordered pairs is 1, 4, one of my ordered pairs is 2, 7, and another one of my ordered pairs is 3, 10. And then I close my brackets. So that's our list of ordered pairs. All right, next, we can also represent a relation with a table. Okay, we define our table with x and y, our independent and dependent variable. So let's take the same numbers and put them in the table. Our x's would be 1 and 4, 2 and 7, 3 and 10. So that's a table or a T-chart. Next representation is going to be a mapping. Now, a mapping is very similar to a table. Okay? Normally there are 2 ovals. The x's are all listed in one oval, the y's are listed in another. So I'll have 1, 2, and 3. And then I'll have 4, 7, and 10. And then what they'll do is that they'll draw lines to show the connection between the two. So 1 goes with 4, 2 goes with 7, and 3 goes with 10. Okay? Now the reason that the lines might be different is if the ordered numbers were in a different order, and then you might have 3 to 4 or 1 to 10, depending on your order pairs. Alright, the next way is with a graph. Okay? So we can show ordered pairs on a coordinate plane. Okay, so 1, 4 would be about here, 2, 7, 3, 10. Okay, so we have graphs. All right, and then the last way is with an equation. We would say that f of x equals 2x minus 1. Okay? So, a relation is a set of ordered pairs. We have all of these different ways to express the relation between different sets of data. So, now, let's turn to the next blank page in your iPod. And what we're going to do is we're going to create a Frayer model. So you've done this before. You might have glued one in. If you didn't glue one in, it's fine. Okay. So what I'm going to do Alright. Now, the word that we're going to define is the word function. Now, a function is a special type of relation. So if you had the idea, think about a box within a box. There's this, you don't have to draw this, I'm just trying to show you. There's this big idea of relations. And then within that, you have another idea, functions. So So all functions are relations, but not all relations are functions. Just because you're in the relations box doesn't mean you're a function. So let's define function. Okay. So our top left-hand corner is going to be our definition. Okay. A function is a relation. So again, we're talking about ordered pairs or sets of data where every x value has exactly, and we can underline the word exactly, one y value. Okay? And the way that we paraphrase that, and the thing that you'll hear your teachers say over and over, is that in order to be a function, x cannot repeat. Okay? For every x, there's exactly one y value, or x cannot repeat. Okay? So that's our definition of a function. Next, let's talk about characteristics. Alright, so we already said one characteristic is that x does not repeat. So when we look at ordered pairs, when we look at tables, when we look at maps, we look at our set of x values and ask ourselves, do we see that x value more than once? If you see the x value more than once, then the relation is not a function. Alright, so that covers 3 of our representations, but what about the 4th representation, the graph? So when we look at a graph, if you can draw a vertical line that touches more than one point, on your graph, it's not a function. Alright. Okay. Now, obviously you don't have this in your iPod, but I just want to show you an example. So it's called the vertical line test. So whenever you have a graph, you take a pencil or your finger or something long and you move it across the graph. If your pencil touches the graph in more than one place at a time, then this will not be a function. So when I have my pencil right here, am I touching the graph in more than one place? And the answer is yes. If I drew an imaginary vertical line right here, I would be touching my graph here, here, and here. This means that this is not a function because our x's are repeating. This point right here is what? 1, 2, 3, 4, 5, 6, 7. So this is 7, 2. This looks like 7, 5. And this looks like 7, 7. So that's the x, x, x. 7's repeating. As I drag my pencil across this line, do I ever touch the line in more than one place? And the answer is no, I do not. This is a function. Like we said, definition. A function is a relation where every x value has exactly one y value. So here are some examples. We can make a list of ordered pairs, right? 0, 1, 1, 2, and 2, 3. I look at all my x values. I say x does not repeat, therefore it's a function. We can draw a graph like the one that we saw earlier. This is a function. It passes the vertical line test. Or we could look at a table and say, okay, my x values are 3, 6, and 9. X does not repeat. It's a function. So let's look at some non-examples. Okay? What if I had a graph that looked like this? Is this a function? The answer is no, because my graph does not pass the vertical line test. And then what if I look at this map right here? Okay, because I have the point 3, 6, and 3, 2, this x is repeating, and therefore it is not a function. So go ahead and fill out the form at the bottom of the page, and we will discuss functions and relations more tomorrow in class. Have a great evening.